Isn't this trippy or what? Okay. So I'm attempting to fix this little overlay here. So where can we put that so we can see it? Okay, great. Um, so huge thank you to Jason Long who designed our logo. Very, very, very cool. I know everybody is extremely excited about this. And here it is. And so I'm trying to overlay this image on so that it'll be visible when we're in the terminal because we're doing a lot of stuff that's not in the terminal right now, but um, would like to get to the terminal. So let's see. Okay, and I believe there's a filter on there. So oh yeah, this was the trick. So basically I tried to put this opacity application via the color filter, and white is is only one number because FFFFF, if it overflows, then it's white. So that means that um, OBS, I think OBS maybe has an integer overflow there, either that or its intended behavior, but I don't know. Or maybe I'm wrong altogether. So, all right, I don't know how to do this, and this is why we're on the video because then, in case anybody else wants to know how to do this, because it's hard to find these little clips of these things with weird, editing software. All right, so because we all want to make, some streams here, so some videos, so it'd be good to have this information on there. All right, so color correction. I guess I could just Google. Color add, I think we want to color add white. Okay, that looks perfect. And then opacity. All right, there we go, right around that 60 mark. That is perfect. Okay, okay, that is, okay, don't, maybe somewhere around here. Yeah, great, perfect. All right, let's export this. Okay, great. Okay, we are live and direct from the 160. All right. So, I'll move this over here. Okay, so where were we? Um, well, when we left off, oh, and I saw something while I was on Twitter, and this looks interesting. We can maybe leverage it for some visualizations. So basically, we're getting everything in and out of the network. It's too dark in here for me without this. All right. it creates a giant light behind me. You probably can't see anything, but doesn't really matter. So, because what matters is on screen. So this is just reminding you that things are still happening if I'm not talking. Let's see. So, okay. I think we looked at last night the key situation. So where were we? I think we were in Documents, Python. Um, let's see. Uh, Active Directory. Were we in there? I think we might have been in here. Where is that? Where was it? Where was the file? So we wrote this little test file. Where did we put that? Did I put it in a temporary directory? I always do that. Never the wisest idea. Um, what was it called? It was called, oh, but that actually ended up being DID com, and then we basically decided we want to use pure DIDs. Okay, so we're just going to start from here. So example, encryption keys, verification material agreement. Okay, signing keys, service, DID com messaging, service endpoint, fantastic. Okay, okay, nearby, what is this? Telnet options. Okay, that must be something else. Okay, so example code. But let's just try to pull this down. And then there was, yeah, this note about static layers of support. Yeah, we had been reading this back. I think we pretty much determined that, you know, we want to go this route. So let's just try to run some code, and because we want to just try to get something in this format. So where are we at? Peer DID. Okay. Okay. And we had this stuff here. So I found out the other day that you can actually do stash with a message. So we're going to say, what does it look like we were doing here? So it looks like, oh yeah, experimenting with alternate syntax for data flow definition. Okay. Let's just make sure that we know where we're at. Okay, great. Data flows class up to date. So let's pull, let's check out main. Let's pull. Okay. Okay, great. That all looks good. Okay, so then let's see. So how should we handle this? So I think we need to make a plugin. Everything's going to be an operation. So let's make a operation plugin. So we're going to do we're going to get status. Or wait. Okay, here we are. Here's where we are at in history. This might get rewritten somewhat. because of more PDF files in there. Um, but generally you can rely on the fact that this commit name will be unique. So pure DID Python. Okay, so all right. Okay, where's the docs? So let's show how we would figure out how to do this. So basically, we know we want to implement pure DID support in DFFML, right? So we're going to go and look at the existing documentation, which is really zoomed in, now really zoomed out, and we're going to go figure out what's the latest version of it, right? So, and we're using this as an example. I mean, we're doing this for our own project, but this is a general template you can follow for how do you go find out what you need to do, and where you need to do it. So you identify the problem space, and then you get up to date on what the unfilled piece of that problem space is, and then you um, attempt to identify connection points to the most reasonable areas for expansion that are already widely deployed. So we determined that was Web3, DIDs, and but we have our own ML built in, right? And then we're going to mesh all of that to be the ML definition on top of that. Um, and so now, we pick where do we want to begin first, right? And because we are, going to be implementing the control feedback loop within DFFML, and DFFML is obviously this is our project, right? So this is our place where we do things. So we're going to implement it here. And then once we have it ironed out, right, once we know how it works thoroughly, then what we'd do is we'd say, okay, KCP, here are maybe, you know, what of this stuff actually makes sense that other KCP, we would go out and we would talk to other KCP users, and we would look and we'd see, hey, are we doing some of the same things? And then we'd come together and we would write, some specs around like what the ideal, after doing an analysis on our shared, things that are running on top of there and the modifications that have been made thereof, then you sort of figure out as a community which of these things need to be incorporated most into the main feature set. And you don't want that feature set to grow too much, right? So that's where, you need to figure out where are the roles and responsibilities of each project as it exists, like within the open source ecosystem that we have. Um, and then, you attempt to put your changes in the place that makes the most logical sense. And you try to do that and distribute the changes across the projects logically, so that, um, you know, basically don't, it's kind of like we talked about with the option to, um, it's what we talked about with the option to set these config values for the sizes of files created, where you need the ability to configure all the way down. Um, um, yeah. Okay, so let's just get going. Okay. So yeah, so you need to be able to configure all the way down, which is why we have this configuration structure. And so we're going to map the configuration structure to the DIDs, to the input networks. Um, and that will allow us to basically take these data. We're going to take data and we're going to act as like the the this open architecture which we're proposing acts as the highway upon which the data travels, right? Um, it's the infrastructure and it's the commodity. Um, it's a hybrid. um, what what we're doing here. We're because it's self-descriptive in the way that it's executed as well, right? So a it's like an instruction manual. It's like if you're selling things on the blockchain and it's like, you're selling because you are selling things that are on the blockchain because they're like little robots and stuff, right? And I mean, they're not just like little robots that are moving around, but there's all these devices, right? And so they're all on the blockchain. And so how we interact with them, if we interact with them through this uniform way where we've defined this open system for which allows for sandboxing appropriately. Right, this is this data flow format, right? I mean, the data flow format is one of the execution formats within that, but this is this universal blueprint, the open architecture, the system context, right? From the discussion thread. Um, and so yeah, so basically, then in the interpretation, so the manifest is how we're going to encode um, the manifest is how we're going to encode the system context, and then we put the manifest on the chain. And we're going to put it on the chain using the peer DIDs. Um, so what we're trying to figure out right now is we identified that we're putting this is that we did an analysis of what code bases are we know we're going to be involved for our effort here, right? We found the technologies in terms of like the protocols and the formats and stuff that we want to build our stack on top of, right? And we um, then we figure out what our first target project is, whether we're contributing to an existing project or we're starting a new project and then proposing that for contribution within another project, or we're saying basically a hybrid thereof where we have an existing project because it's part of the overall solution that we're looking at. And so we're just going to prototype very similar to one of the well, so we're just going to prototype uh, what's another analogy for this? Um, it's like it's like having a fork of a fork. Um, so, or it's really just like having a fork, basically, right? So basically, like imagine that this imagine that we basically like we're not actually using any of the code of these projects of the pure DID or KCP, right? But we are you know creating things that conform and leverage their interfaces, right? Um, and so we can, because they provide these extensible, the way that the ecosystem is centered around like these formats and interfaces, because when you center around formats and interfaces, you allow for multiple implementations to evolve, and you allow for um, 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 you allow for multiple implementations to evolve, and yeah, that helps you do this process by which you basically have all these forks, and so you're just sort of you're seeing this natural like so you're thinking of the different repos and the different feature branches within them as these trains of thought, right? And so you have this natural expansion because like the software engineers just sort of go. You try to tell them to do things and then they just end up on Google, right? And because that's all of us, right? Like, I mean, how many times have I said it? Probably within the last 5 minutes. So it's like I'm just gonna go Google this. So the thing is that um, we have to, we want to like, it's like preemptively doing that, right? So um, okay, no, we're getting into a whole, the thing is, okay, so it's okay. So what we're doing when we leverage this DID, let's see. So, Okay, so no, it's all sort of the same thing is the thing. Um, so when we look at a fork of, so there's a repo, right? So there's KCP. So say we were to fork KCP, right? And then we start doing our KCP related changes directly in our fork. All right, well, that's all, fine, well, and good, right? But sometimes we may just want to so if you look at like how distro works, a Linux distro, they have build scripts that basically take the upstream, apply patches on top of the upstream, and then that's the version that they're using, right? And so that in itself is sort of like a one-stage data flow, or maybe, an n-stage data flow. But, it's defined, the execution environment is defined in the plugins. Effectively, the plugins for the operations, there aren't plugins for the operations. They're the ones that are statically coded into the package management system or package build system, right? For which pieces of the package you should build. So what we're saying is it's the same thing as we're saying with the data flows, where if you, instead of focusing on feature data and sort of models as separate things, but focusing on the interface between them, it would allow you to, mix and match these things, right? And then you have this decoupling, and then you can do your auto ML on um, um, your hyperparameters, and then you can also do your auto ML on your feature engineering because you have the ability to rewire what features are in your data set, right? Um, and so when we do this, when we do the auto ML on feature engineering, it's the same as what's happening when a project in an open source project, it is forking, and then you keep seeing these forks and forks and forks, and you get this sort of ecosystem, right? It's basically it's the same thing. You're looking at the same thing. You can collect all that data on the open source ecosystem, and you can analyze it using this model, right? And this model itself is the open source ecosystem is a byproduct of the communication, the speed of communication as it propagates through the open source community network, as well as the speed of validation of these ideas, with which is directly related to the number of users adopted and like sort of how battle tested the software is, right? And once you get more battle tested software, then it allows it to grow market share, and more people can try their edge cases and use cases on top of it. And when you find those edge cases, then you generate your new trains of thought, which is where you are having, your forks, right? And ecosystems are sort of around the formats, and then the projects are having their forks off of them, and each fork sort of represents maybe like a feature branch, and um, the feature branches represent a train of thought, and a train of thought is a direction that we're working in. It moves one system. We watch the system context like tick tock, tick tock, tick tock from one to the next, even though it may be done in a massively parallelized setup. But effectively, if you were to just look at them flattened over time, you're watching it tick tock from state to state, right? Because you're always moving, you're always either thinking of a new state, executing the state, or you're yeah, thinking of the state or executing the state, um, or it's executed. Um, there may be a few more, but basically that maps to each commit, right? And so then the validation of each commit maps to the CI/CD for that commit. And then what we need to do is we need to sort of preemptively validate the changes of each developer in each permutation of each commit in each developer's feature branches against each other, and that will give us sort of the best the 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 edge of field, right? So this isn't upstream. This is bleeding edge, basically, right? So this is what is the latest auto-validated version of the all of the feature branches tested in all of the permutations against each other, right? So this basically generates your dev build from all your developers with all your feature flags essentially, right? And you know your compatibility matrices so that you can release different subsets to different users. And you are using these strategic plans that are overlaid on top to do the analysis pre-execution of each of these system contexts to say um, hey, like basically, is this within my risk tolerance, right? You're proposing so strategic plans. So, so strategic plans both propose and vet. Uh, the strategic plans both propose and vet new system contexts as are running through the network. Um, this thing too much. I do not think I did. All right, so yeah, so strategic plans they propose and they propose and they vet things. And okay, so this maps to basically the risk tolerances of A/B testing these feature branches of the developers against each other, because you have certain times when you need to test things in live environments based on resource constraints. So say maybe you have staging dev prod, right? And maybe you want a dog food user Bob. Um, with basically this bleeding edge version, right? Which would mean that you're going to take all of your software developers' changes and you're going to um, you're going to test each uh, each delta each delta, and I think it's like some sort of inclusive, or you're going to test each delta and you're going to basically cherry pick. I think you're basically going to cherry pick like matrix multiply all permutations type of thing. Yeah, I think you're basically going to cherry pick all permutations, which means you have to cherry pick. And this is what I meant by when I said like inclusive. It means that if you're going to cherry pick all permutations, then you have to apply the ones that are like before that. So, and then basically, and you basically, and so you do that for all the permutations, and then you run all of the tests, right? And so, so here's the thing, right? Not always are you going to catch you're not going to catch everything based on that, right? So because some people may not have written tests yet. Now, how do we mitigate that? Well, we're going to, obviously try to keep our the locality of our focus, right, to these function scoped objects that focus on the data and the transforming of the data, right? And so we're going to try to wrap up the docs and the tests and the execution into these single files, like with our ADRs who are restructured text files right now, or our Python files. I think ideally we'll end up with a situation where our Python files, where we fix the syntax highlighting in Vim and VS Code to support like this nested syntax highlighting when editing, so that basically you can edit your Python file is your unit of reuse, and then your function within there can be plugged and played with anything else. And yeah, so and then obviously all of the wrappers around existing specs and protocols and things which can be implemented themselves as just little functions. So the goal is like the completely just like as modular as possible of a design, right? And compatibility with existing um, interfaces. Uh, okay, so let's check out a branch. Okay, CD operations. Here's the rest of our operations. Let's get diff service dev operations, diff operation. Peer ID. Let's see. Operations. Yeah, there's some bad inconsistencies with the use of plurality or not plurality in here. So then now we see here, and now we're going to do, oh yeah, I was going to pull up, that's how I got distracted. I was going to pull up the getting set up to work on the operation security. Plugins, plugins, plugins. Okay, yeah. So here it is. Basically, if you go here, this is what we did. It's basically, if you want to contribute it to the repo, which is what we're doing, we're putting it upstream right now. Then you better put it in this directory. So we're going to say peer ID. So now what we're doing here is now we're going to check out our branch, right? So diff operations peer ID. And we'll preface it with Alice. Well, everything is going to be basically Alice. So, all right, check out view peer ID. Okay, and now we jump on in there. We're going to give it the old get status. Oh, actually in here, when you create an operation, you need to remove the .git directory. So we need to update gh issue create scale common, or wait, no, so docs, tutorials, models, package, add note about git deletion if upstreaming. Okay, and here's the body, and this was introduced in docs. Okay, so or no, it was introduced in. So basically, when we did this service dev. Okay, so when we did this, a note about add note about git deletion. So git. So what we did here is we did git log dash p dash dash dot dot slash dffml service dev. Okay, so this is going to tell us where is, what are the last patches dash p that modified, or what are the last, patches dash p, which are commits, which modify this file within our Git directory, right? So now we can just go through and we can look at all this, and we can say, okay, so this is when, okay, here it is. So initialize Git repo, right? So now we can say, you know, introduced by. And we can say, okay, this is where that bug got introduced, right? And so now we have we have better traceability, right? We know, when this happened. So if we were to go and think about this from the perspective of automatic validation of it, then I forgot I did this. Keeps it out of my hand. Okay, so If we were to go and look at this from the perspective of automated validation, I think this has to do with the bisect stuff. I think there was a note in there about bisect the other day. Um, so yeah, okay. So what is that? So we see and this relates to, so we're going to try to do this like sort of anomaly detection to try to understand, when are things, not characteristic, right? When have we triggered new paths, kind of like we're fuzzing. Um, and um, so I think if we will use the strategic plans to, yeah, do sort of clustering models, anomaly detection, whatever. And um, I think we can say like, oh yeah, okay, we were going to snapshot the entire environment when we run our tests and when we run our system, like when we run a system context, right? And so you can basically, the goal here is to allow for configurability in the amount of data collection as well as the amount of, configurability or like, hooks into things, right? So um, we can basically run the orchestrator. Whatever orchestrator we run, we can set up. Um, we can set it up so that it somehow allows us to reach our hooks in there, and save that state. Because if we can save that state, we can inspect that state, sort of like we're using the strategic plans as like the generic brain of the fuzzer, right? And then we can try new we can see which things moved strategic plan outputs. And if you're moving the strategic plan output, then you're if you're moving the strategic plan output, then that means that there's some kind of anomaly. It might mean that there's some kind of anomaly, right? And so basically, if we had something that went and detected all the files that were created within a test case run, and we saw that this .git directory is now created, right? We could say, hey, anomaly. There's a whole bunch of files that were created, right? And so this is sort of like our adaptive sandboxing technique. So we sort of build these. Yeah, we're basically building these profiles of the trains of thought as if they're like workloads, and then we're sort of applying the adaptive sandboxing is this anomaly detection, which decides basically what to do based if there's an anomaly. It detects the anomalies and it decides how to respond to them on a case by case basis by feeding into other strategic plans, which take the outputs of the previous strategic plans as inputs, and each one, if you look at it, forms like a layer. I think it forms basically a layer in a neural network. If you look at each of them, and so yeah, but I'm not sure about that. I mean, they're feeding like that. I guess maybe we'll find their values. I think we'll find their values if we put them all together. I'm not sure how though. How would we do that? I think, yeah, I think it'll end up mapping them. I think by training the data set, it basically just ends up mapping it all into and essentially encoding it. Oh, is that the language model? Is it acting like some kind of encoder? I think we need to encode, yeah, we need to encode the strategic plan outputs as if they're like the conceptual layers into weights in a neural network or something. And how could we do that? Weights in a neural network. I'm pretty sure. As if they're weights in a neural encode. So how do you do that? How do you do that? Well, you basically run predictive models. Okay, encode the output of the strategic plan into weights in a neural network. And then the output after that on the final layer is basically these strategic principles. So you need an encoder to encode the strategic plan outputs into the neural network weights. And you can do that by into the neural network weights. Is it in there? I'm not sure if it's worded in this way, which is why I'm struggling with this. I think it's in too many bits and pieces all over there. So I'm trying to word it in one cohesive thing or pull it out of here. So you can do this encoder, and so you can create an encoder by doing essentially these multi-output models where the outputs you do all these permutations. Oh yeah, this is what it was. So you do all these permutations of um, multi-output models for the feature engineering and with the hyperparameter tuning. So AutoML on these strategic plans, um, and against each other, and then let's see. So you're using one plan to predict the other plan, and then you need this encoder to encode the weights. I think maybe you're not really encoding. I think effectively what happens is you basically just permutate over everything, building models where applicable, build every applicable model that shows correlation between all I/O. Um, Looking at all I/O as in all the way down through every system context where all the permutations are defined by the calculated risk and risk tolerances with applied overlays for any specifics for the for within the top level system context. So basically, like, don't spend too much money on CSP time or something, but go experiment, right? Um, so yeah, and how did we get on this? Basically introduced in blank. So we were attempting to explain the A/B testing and how we would, cross-validate feature branches combined with A/B testing to users to understand what individual commits introduce bugs. So basically, to go, sort of like um, we're trying to understand. Basically, we do the risk, we do our risk assessment and allocate to users appropriately, where users are use cases, are data flows, are executed system contexts within the chain which have low risk, depending if or within an acceptable risk tolerance, right? So this is your, okay, I'm gonna try, right? I'm like, okay, okay, so so okay, so we have to think like, yeah, okay, so yeah, what are you going to do? So basically you're going to go try, so you want to test this 10 gigabyte, um, 20 gigabyte, whatever thing, right? Okay, or no, you were on, what was it? We're on a 100 megabyte disk, right? And so then if we had, the limit was 200 gigabytes, it's not going to work, right? So we somehow generated a system context right? So we generated a system we thought a thought, right? We thunk a thought. We thunk a thought and we generated which is a new system context, a new system context in the hypothesis state, right? Without like the executed values is, or maybe there's like there's maybe like an idea, a hypothesis where you're proposing some outcome, right? And that's the running through all the strategic plans to get to get the output results. And then there's the executed value, the ground truth as declared by whoever signed that DID, right? Or is associated with that DID. And this is what allows you to pick and choose what data you want to work with in this environment. As if you are, for example, in a AI that is sort of just floating out there through all of these devices, you can basically say, this is the data that is applicable to my strategic plans, and therefore this is the data that I need to consume, and these are the DID peers that I need to traverse, right, to perform whatever task at whatever particular time I'm trying to perform in guidance with my strategic plans, which are have this signed provenance information included via the verifiable claims. So this so we were talking about the 20 gigabyte limit. So basically you've got this mesh of devices out there, and you say, hey, so somebody go try this experiment, right? Well, it's like, well, what's the risk cost? Okay, what's the analysis? Basically, like, I need something with 100 megabyte drive that can try to create this file. So whoever can go execute me that flow, I would be really happy to hear the results. Thank you very much. So you send it out there to the DID chain, wherever you want to do that, and we have this generic proxy infrastructure on top of that, so you could send it wherever you wanted, right? But you're just using the DID and maybe hopefully this optionally, encoded with CBOR, to transmit these things around over different protocols and transport mechanisms, so as to create this like mesh network across yeah, protocols and transport mechanisms. So whatever, same thing. So then you um, get into like this like issuing of reward and like incentivizing certain behaviors. And so because you want to basically like influence the agents within the network to produce metrics that are beneficial to some of your strategic plans. So this is like, when you're detecting alignment, and when you're, killing two birds with one stone sort of thing. So if two agents are executing trains of thought, which are, similar by some measure of similarity, there's some measure of similarity, basically an encoder decoder model. I'm pretty sure that's going to encode the system context to some sort of like, you know, stream, right? So we're going to be able to represent these. We're going to need to represent these system context as some stream, some sort of thing that maybe it's like some sort of like kind of like DNA thing where we can sort of, I think maybe it's this. It's something where we can basically like really understand what makes these things similar to each other, right? And I think what makes them similar to each other is really just, oh, I guess you're probably just going to run strategic plans over them that say what is similar within this context, just as the same way as you're going to say what do I want to do for this deployment environment for this top level system context, right? So I'm just like running from the command line or whatever. Okay, great. So okay, so we're going to delete a bunch of files we don't need right now. Okay, been meaning to delete that. I think we're going to delete the docs folder because we're within upstream right now. And we are going to delete the tests. No, do the tests run? I am not sure. Yeah, I think the tests, I didn't clean up that sticky thing. I think the tests, think the tests, I think all we really want to do is the same thing that we've been doing, where we're going to do our doc testable examples because we want to, obviously prototype with that. We want to do what we're talking about here. All right, so what are we looking at? What's the damage? So a couple of files here. So what do we got? So we have our plugin, right? And let's open up. So we should safely. Okay, so let's look at the README. It's probably just garbage. Yep. Okay. There's nothing in here. So you're probably used to seeing setup py files. So now there's something going on where we're shifting. The packaging ecosystem in Python has been changing over the past few years, and they're redoing things. And there's this sort of general acknowledgement in the community that, hey, we really shouldn't be executing code when we go and do builds from random dependencies that we grab off the internet, right? So let's stop using Python files and let's switch to, maybe something a little more static, like basically a TOML file. I think they finally put the TOML parser into 3.10. Maybe not. I swear I saw something about that recently. Okay. So here's, all our random little package data. So, I think that we're actually going to move. I think it almost makes sense to move even farther away from this because we want to. I think we're going to try to keep this as lightweight as possible, which basically means we're going to kill all the packaging stuff. And we're basically going to assume that Alice is going to package this for us down the road. So we're just going to get rid of all this. We're actually not going to use any of this. The only thing, we're not going to use any of this. We're not going to use any of this at all. We're not going to use any of this. So the only problem with that is then you're tied into this build tool. Alice is a build tool. Okay, so you can't basically just directly point it at anything because you're stuck using the build tool, even though we love the build tool. So in that case, it doesn't really matter because what we'll do is we will have the stuff get basically just auto-generated and you can commit it to Git, right? There's no reason you can't just commit it to Git and we can do, Delta. So, but we're just going to delete it for now. So we're basically just gonna wipe out all this stuff. We actually don't want any of this. All right, let's just go in here and start hacking. Okay, so what do we got? Pip install pure did. Okay, so let's go ahead. I'm wondering whether to use pip envi right now. No. We're just going to do it this way. So, okay. Operations pure ID. So, yeah, eventually we would have something that, let's see, eventually we would have something that just like automatically wraps. Basically, eventually Alice will be able to automatically wrap any library for us by doing introspection on the AST. So that would be, the next step here, right? Basically, determine what build data flow, which is analyze source code, understand APIs, exposed APIs, understand unexposed APIs, and if you could rewrite it programmatically and refactor it programmatically to expose those unexposed APIs, and then map those to your data flow construct, and then you can do synthesis or dynamic execution. With either of those. So, great. So, all right. Okay. 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 All right. All right. So much information. Okay. 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 I'm just trying to get everything out here. So, because I know the notes are a little bit hard to know that I'm not. I'm sure this is not that much more coherent. Unfortunately, this is the just live editing basically thoughts. Okay. So let's go ahead and install. So let's do async def. Um, this is not, okay, let's go check out the CI. Or let's go check out the tests. So did doc resolve, create pew did, no mail goes 0. Yeah, we'd get a lot of mileage out of hooking into PyTest. Okay, so PyTest param did doc. A little bit because it does work. It works for its scope, right? But we're working at sort of, we want to work across projects, right? And this is, obviously it's for within a project. So it's like conf test scoping. This would be like a conf test for across projects that would knit all this stuff together, but use it in a real setting instead of as a test. So, or support using it as a test. Okay, so test did doc from JSON, no malgo 0. From JSON, did doc JSON. Okay, so does that actually run this? Does that run this? Okay, I guess we have a more helpful GitHub here. No, we don't. Oh yeah. Okay, so test vectors. Okay, so we want to go into test vectors. Okay. I like the way that this guy does things. This is good. Why these are strings I don't understand, but whatever. Hmm. Okay, so what are we seeing? So I'm trying to figure that out. So what are we seeing? So did doc peer ID from JSON. So it looks like we've got a bunch of these authentication, authentication, authentication. Let's go reference the spec. We just want to put some data in there. Remember, that's our goal, and then we can move on. Once we can confirm that we can put the data flow in there, we can move on. We need to be able to just throw a giant base64 encoded blob in there, and then we'll be happy. Because at a minimum, we throw a full data flow in there. Encode is a zip file. I only keep saying that because there's okay, so what is this? This is the ID com messaging, which is based off of the DWNs, I believe, service endpoint routing keys, except, yeah, so my understanding is that, there's things that interpret this, and we might be one of the things that would interpret this. Well, maybe that's how it works. We're interpreting this, and then we're going to go to that endpoint. Um, I'm not exactly sure. Service endpoint. Yeah, I think that does mean, I think this is where we're going to say, hey, here's service endpoint routing keys. Yeah, I wonder what you can do with service endpoint. I wonder if it can be another DID. Or maybe it's like service endpoint. Service endpoint. Let's read about it. I think this might be like the operation implementation network. Or maybe like the operation implementation. Or this is service is service is a input. The items in service are an input or are data which can be given. So each object in service, right? So basically service itself is a key, right? We will grab, so basically when we execute the data flow for, let's just do this. Okay, what license is this? Apache 2. Okay, so we're putting our SPDX license identifier at the top of our file. And we're saying we got the following from here. And we got it from line 57 through 96 specifically on this commit. Right? So now there's no question about it. Okay. Actually, well, 58 through 95, because we only want this. Okay. So this is, what is this? Is this a DID doc? Authentication is also inputs. All of these become inputs. All of these become inputs. All of these become inputs. And then Ah, shit. Alright, I gotta stop now. So it should introspect and map to orchestrator or map to creation config. Alright. Bye for now.